Okay. Uh, Hello, students. Uh, I am Professor Manoj K. Kumar Ghosh, Department of Chemistry, Bharati University, Durg. Today, I discuss about the research methodology for PhD chemistry. It is present in your syllabus, Unit 3rd. The first topic is present in Unit 3rd is electroanalytical techniques. Now, I am discussing about the electroanalytical techniques. What are the electroanalytic techniques? Okay, so electroanalytical techniques are a group of instruments or instrumental techniques through which we can determine the potential, current, and frequency of light through this instrument. So, there are generally in UG program we can use here the four techniques, and it is also used for the PG program and PhD program. First is potentiometer, and second is voltmeter, and third one is conductometer, and fourth one is colorimeter. These are the four techniques through which we are determining the all the parameters through which we can analyze the physical property of any chemicals. All these techniques are interaction with electricity, with matter. We also measure the electrochemical properties like potential, current, charge, etc. with the help of different instruments like potentiometer, pH meter, conductometer, voltmeter, etc. The use of electrical measurement for this analytical purpose has found large of applications, including environmental monitoring, industrial quality control, biomedical analysis, including analytical chemistry. So, we come to the instrumentation used in electroanalytical technique. First of all, I discuss about the electrochemical cell. What is electrochemical cell? In electrochemical cell, oxidation reduction, and this is also known as redox reaction, where the oxidation and reduction reaction are simultaneously go on. This reaction is known as redox reaction. So, in electrochemical cell, redox reaction takes place in a electrochemical cell. Here is given the one very good example of electrochemical cell. Suppose you can take two beaker. In first beaker, you can dissolve the zinc sulfate and dip a rod of zinc, and in second beaker you can dissolve the copper sulfate, and you can take the electrode of copper and both are the connected through a wire, and between the two beaker you can use a salt bridge for the mobility of ion. This is a very good example of Daniell cell or galvanic cell. This reaction occurs in this cell is a spontaneous reaction. But in the case of electrolytic cell, the reaction is occurring non-spontaneous. Basically, from childhood we know that what is oxidation. So, oxidation, loss of electron is known as is oxidation, and it is occurred at the anode. Remember, oxidation is occurred at anode and the reduction is occurred in the cathode. Okay, cathode is denoted by the symbol negative, anode is denoted by the symbol positive. Here is another example of galvanic or voltaic cell where the reduction reaction in a galvanic cell is a spontaneous reaction. Here is a given that a figure, a common galvanic cell is a Daniell cell. We already discussed in earlier slides. If we join a voltmeter between the copper electrode and the zinc electrode where the potential difference is developed, then the current is flow, right? So electron is flow from the anode to cathode, because we know that the very simple definition of electricity is flow of electron is known as current. Here, from anode, electron is flow towards the cathode, and the EMF generated at the copper is plus 34 volt. Similarly, for the zinc electrode, the EMF is generated, that is 0.76 volt. By the use of Nernst equation or electrochemical cell, the potential difference is developed in zinc electrode and in copper electrode. For this purpose, you can use a zinc rod or zinc electrode, and for copper electrode you can use a copper rod, and the reaction is occurs mentioned in your slide. So come to the second point. What is electrolytic cell or non-spontaneous reaction? When electrical energy is required to induce the electrolysis reaction. Suppose if you take a gas like chlorine gas, it is collected surrounding on the cell. Suppose sodium metal is less dense than the molten salt and is removed as it is flowed to the top of the reaction container. Here is the figure where you can use the two electrode, one is anode and second is the cathode, and you can dip or dissolve sodium chloride solution, and on electrolysis sodium is moved towards the cathode and chloride ion moves towards the anode, because we know that opposite charge attraction and same charge repulsion. Here sodium is a positive charge, so it is attracted towards the cathode. So current is flow from the anode to cathode, and if you attach with external wire with a battery, then EMF is generated, and you can measure the EMF developed through this cell. Now we can come to the classification of electroanalytical techniques. What are the classification of electroanalytical techniques? In electrochemical method, it is classified in the two ways. First is potentiometer, second is amperometer. So come to the first point, that is potentiometer. This is a technique. In potentiometer is a kind of electroanalytical technique. In that the potential difference of a solution between the two electrodes is measured with the help of electrochemical cell without drawing any substantial current from the solution component. Now, potential at the surface of indicator electrode is then related to the concentration of one or more analytes based on the Nernst equation. This is called direct potentiometer. Thus, the number of electrons involved in this reaction is oxidation plus number of electron is denoted by the symbol N. A electron is denoted by the symbol E negative. A reversible reaction is occurred and the product is reduction. The potential of the electrode is the EMF through Nernst equation. This is the Nernst equation. E is equal to E0 RT by NF log activity oxidation by activity of reduction, where E0 is the standard electrode. So come to the titrimetric titration. First is potentiometer titration. In instrumentation of potentiometer, what is potentiometer titration? In potentiometer titration, after adding up each ml of volume, increment of the standard solution to the analyte solution of potential, that solution is measured with the help of indicator, that is indicator or electrode, that is called potentiometer titration. Here now come to the classified electrochemical cell. Electrochemical cell is used in potentiometry for the measurement of potential difference of a solution between the two electrodes without drawing any substantial current from the solution component. In electrochemical cell consists of salt bridge, reference electrode denoted by the symbol E reference, salt bridge is denoted by the ELJ, analyte solution, and indicator electrode is denoted by the symbol EIND, indicator. Here is the given a very good example of E cell is equal to E induce minus E reference plus ELJ. Here we are taking two beaker where we can attach a salt bridge. In first beaker you can use saturated KCl solution where silver electrode is used, and in second beaker you can use indicator electrode or any reference electrode. When EMF is generated, it is detected by the potentiometer or digital voltmeter. This is the another example like calomel electrode and hydrogen electrode. Hydrogen electrode is a reference electrode. Okay, this is the techniques through we can determine the potential of any salts or electrolytes. Here is the given that the types of difference reference electrode, that is a standard hydrogen electrode, saturated calomel electrode, silver electrode. Okay, these are the application. Clinical chemistry, it is used in clinical chemistry. It is also used in environmental chemistry. for the determination of potentiometer titration, for the determination of agriculture, and lastly, we discuss about the manufacture of detergent. We can use the techniques for the manufacture of detergent like calcium, barium, fluorine for studying the effect on water quality. Last is food processing. We can use also this techniques is used for the food processing. Okay, thank you. Have you any question, any queries? No. Okay, thank you.